All right, guys, we are going to use graphs. We're going to use some graphs to solve some acceleration, velocity, and distance problems, all right? Now, in order for us to do this, we need to understand the information can be derived from one graph and be translated into the next graph, all right? So that's what we're going to be doing. We're going to start out creating a graph of acceleration, and then we're going to come all the way down and create a graph about distance, all right? Some things that we need to know. If you have an object like this and you drop it towards the earth, its acceleration towards the earth is 9.8 meters per second per second. This is called gravity. So an object that is near the surface of the earth, if you drop it, it will begin accelerating towards the earth at 9.8 meters per second squared. In other words, after 1 second of falling, it'll be going 9.8 meters per second, and then another second later, it'll add another 9.8 to that, and it'll be going 19.6 meters per second. So you increase by 9.8 meters per second every second. That's how gravity works. So we went outside today, and we took a tennis ball, and I bounced the tennis ball off the ground, and we calculated how long it was in the air. Now we're going to say that this tennis ball was in the air for 3.2 seconds, okay? What that means is it went up and it went down. Well, guess what? That means that it fell for 1.6 seconds. So if a tennis ball falls for 1.6 seconds, if a tennis ball falls for 1.6 seconds, how high was it? Now we're going to make some graphs. First, let's make an acceleration over time graph. We're going to put 0 right here. Time always goes on the bottom. This is acceleration, all right? The acceleration on Earth is 9.8 meters per second every second, all right? How many seconds did this thing fall? Well, it fell for 1.6 seconds. So is acceleration steady? Yes. The acceleration was steady. The ball went faster and faster, so the velocity changed at a steady rate. So the acceleration the whole time throughout the fall stayed at 9.8 meters per second. So the acceleration over time graph would have a straight line for the whole 1.6 seconds. So we can look and calculate the area under the line. Well, that's a square. Didn't we just make a square? We can say the height of the square, 9.8 meters per second, times the base of the square, 1.6 seconds, 9.8 meters per second, times 1.6 seconds. That's going to give us a number. That number will be 9.8 times 1.6. That number will be 15.68. I'm going to call it 15.7. And since it's meters per second times seconds, those seconds cancel each other out, and you get 15.7 meters per second. Guess what? 15.7 meters per second is a velocity. That is the maximum velocity this thing was going right before it hit the ground. Let's make that a graph. We're going to make a velocity over time graph. The maximum velocity that we reached was 15.7 meters per second, right? 15.7 meters per second. And that 15.7 meters per second we started out going 0 meters per second, and it took us 1.6 seconds to get there. So that's a steady increase because the acceleration was constant. Now we end up with a graph that looks like this. We got up to 15.7 meters per second velocity in 1.6 seconds. Well, remember how we made a shape here, and we shaded it, and we said the area of this graph is equal to the maximum number on the next graph? Well, let's shade under the velocity. If we shade under the velocity over time graph, now we have a triangle. The formula for the area of a triangle is 1/2 base, 1.6 seconds, times height, 15.7 meters per second. Let's do this. 1/2, 15.7 times 0.5 times 1.6 equals 12.5. 12.5 what? Seconds, and the seconds cancel out. 12.5 meters. Mr. Perkins, what is this 12.5 meters? That 12.5 meters would actually be the height, the total height with which the tennis ball fell. Let's look at that graph. That graph would be distance, x, over time. The time it fell was 1.6 seconds, and it fell from a height, now that we know, of 12.5 meters. And we know, since the acceleration was constant, that we have a constant slope on our velocity. A constant increase in velocity, when we change that to a distance over time graph, creates a smooth curve. So this is the tennis ball falling over 1.6 seconds. The total height was 12.5 meters, so it fell 12.5 meters in 1.6 seconds. The last thing I could ask you, if I wanted to, is I could say, what was the average velocity of the tennis ball? Well, that's pretty easy. There's two ways to solve it. If we're looking at velocity, we could just look at this slope. Now, this one makes it look like a negative velocity, which isn't true, all right? Really, if we were going to draw this curve, we could draw it like this, because from the tennis ball's perspective, when it's at the top, it hasn't moved yet, and then this is it falling faster and faster, all right? So in that case, we would draw the graph like this. Now, that might confuse you. The slope of this line would be equal to the velocity. So here's the simplest way to do it. What's the formula for velocity? Velocity is equal to distance over time. In other words, this thing fell 12.5 meters in 1.6 seconds. So you could just use your calculator, say 12.5 meters divided by 1.6 seconds. Its average velocity was around 7.8 meters per second. So now we learned all of those things through graphs. There weren't any real formulas. The only formulas were, what's the formula for an area of a square? What is the formula for an area of a triangle? Those are the formulas. So we derived all of this information from just knowing it fell for 1.6 seconds on the planet Earth, and that the planet Earth has an acceleration due to gravity of 9.8 meters per second squared. Other than that, we just drew simple graphs. We took it all the way home. So I have a question for you, okay? You can do your own. You're going to bounce a tennis ball. It goes up in the air, and it comes back down. That tennis ball is in the air for a total of 1.9 seconds total. All right? How high did it go? That's my question to you, and that's what I want you to submit. The best way to do it is to draw 3 graphs. Good luck.